Now we will talk about Proterozoic Eon. So the Proterozoic Eon is the most recent division of the Precambrian. Precambrian siya because it occurred before Cambrian period. As we all know that the Dian, Archean, and the Proterozoic Eons, they are collectively known Precambrian. It is also the longest geologic eon because the Proterozoic Eon lasted almost 2 billion years, starting 2,500 million years ago and ending 500 million years ago. During the timeline of the eon, several different events took place, eventually helping to shape the Earth as we know it today. It has the length of 1,959 million years, so it is an equivalent to 43.1% of the geologic time. And it is subdivided into 3 eras. So we will start in the Paleoproterozoic era. Paleoproterozoic is the first of the 3 subdivisions era of the Proterozoic Eon. So as for the introduction, the Paleoproterozoic is by a quite margin the longest era of the geologic time. It covers 900 billion years, about 20% of the entire history of the Earth. This era saw the evolution of most types of bacteria with which we are familiar today, and the earliest eukaryotes. Most importantly, the early Paleoproterozoic included the Great Oxidation Event, or GOE, which we will tackle later on. And this is when the continents first stabilized and the cyanobacteria evolved. Modern plate tectonics began with the Paleoproterozoic. Paleoproterozoic was the era of the continental shield formation. By and large, the Earth's Archean crust seems to have been both fragmented and somewhat unstable. And continental shields formed from small cratons. It was during the Paleoproterozoic that small islands of crust were first stitched together to form the stable nuclei of the continents we know today. These became the nuclei of the North American, Australian, and in part of African continents respectively. The Paleoproterozoic era has 4 periods. One is the Siderean, or coming from the Greek word sideros, meaning iron, lasted from 2,500 million years ago to 2,300 million years ago. So what happened during this time? So this is the fully modern plate tectonics formation of ozone layer. The Great Oxidation Event, it is the oxygen in the atmosphere and formation of the ozone layer which blocked ultraviolet radiation. Oxygen increased from being an insignificant trace gas to at least 0.01% of its present level, and probably to between 1% and 10% of the present atmospheric level. So what does this mean? Because even the 0.001% number would cause the formation of an ozone layer which would block lethal short wavelength ultraviolet radiation from reaching the surface. And breathable air is thought to have been created by cyanobacteria. It's the single-celled microbes living in the sea. These bacteria harness the energy of the sun through photosynthesis, the biochemical process used by plants producing oxygen as byproduct. The oxygen-rich ozone layer was also stabilized, shielding the Earth's surface, and because of this, is abundance of banded iron formation, or BIF. Peak early this period, BIF were formed as anaerobic algae produce waste oxygen that combine with iron, forming magnetite, Fe, H3O4 and iron oxide. This process cleared iron from oceans, presumably turning greenish seas clear. Huronian glaciation begins during this period because in the Hadean Eon, napakainit ng Earth's surface and it continues to became warm in the Archean. Let's proceed to the second period of Paleoproterozoic, which is called the Rhyasian, meaning stream of lava or lava flow, indicating that this was a period of high volcanism. So, because it is a period of intense volcanism, the Boswell complex and other similar intrusions form. It is the mineral-rich igneous rock deposited or the Boswell complex in South Africa. And it is the source of rich mines, contains of the world's chromium, fluorspar, platinum, and vanadium, and contains the richest deposits of platinum in the world. Huronian glaciation period ended in the late Rhyasian 2,100 million years ago because the glaciation or ice age happened at a time when increase of atmospheric oxygen and decrease of atmospheric methane. But during this time, there is a concurrent rapid decrease of atmospheric oxygen, which resulted due to the widespread ocean toxicity, which resulted from the release of toxic elements into the ocean when the ice melted. And many more happened. The prokaryotic cyanobacteria dominate along coastlines and in marine waters. And there's also the Discalma botany, the most probably the oldest known eukaryote, and the molecular clock evidence indicate green algae possibly present because the volcanism of this period produced large quantities of carbon dioxide and other greenhouse gases, and evidence of mobile organism in an oxygenated shallow marine environment. So now we will talk about the Orosirian. Orosirian is the third period of the Paleoproterozoic era, meaning mountain range. This time is the continental weathering develops, bonded iron deposition resumes. So latter half of the period was an episode of intensive orogeny or mountain building on virtually all continents. A supercontinent called Columbia or Nona starts to form. At the very beginning of the period, 2023 million years ago, a large asteroid collision created the Vredefort impact of the structure. The Vredefort is the province of South Africa. And also, the event that created the Sunbury Basin structure that is located in Ontario, Canada, occurred near the end of the period of 1,850 million years ago. And prokaryotic cyanobacteria organisms continue to dominate, and although the eukaryotes is present during this time, however, there is no evidence. Now we are on the fourth and final period of Paleoproterozoic era. This is called the Satyrian, meaning stable, firm. Previous eras characterized by violent events. So what happened this time is the sulfidic deep ocean, no bonded iron deposition, and eukaryotes, acritarchs present. Because during this period, the first complex single life appeared, or the appearance of the possible early eukaryote, the Greypania. This coiled, filamentous appearance, possible green, chlorophyllaceae algae. Greypania could also be a giant bacterium or bacterial supercolony. And the period is characterized on most continents by either new platforms or final cratonization of old belts. And the supercontinent Columbia formed at the beginning of this period. And continents of Ornina and Atlantica drifted together. They expanded through accretion and formed a huge supercontinent. So that's all. And now we will proceed to the next era.
The Neoproterozoic era was a time of transition between the ancient microbial world and the rise of large, complex animal life of the Phanerozoic. It was marked by the final assembly and rifting apart of the supercontinent Rodinia. Multiple glaciations reaching equatorial latitudes, significant banded iron formation returning to the sedimentary record following a billion-year hiatus, rising atmospheric oxygen, significant disruptions to the carbon cycle, diversification of eukaryotic life, and the appearance of metazoa in the fossil record. It is subdivided into three periods. The first period is the Ediacaran period. Around 600 million years ago, the supercontinent Pannotia began to form briefly until 540 million years ago. Glaciations during the early part of the Ediacaran, warm, humid climate during the second part of the Ediacaran, cooling with glaciation at high latitudes occurred towards the very end of the Ediacaran and the beginning of Cambrian. The Diacaran period is an interval of geological time ranging 635 to 540 million years ago. It was a time of immense geological and biological change and records the transition from a planet largely dominated by microscopic organisms to a Cambrian world swarming with animals. It is therefore one of the most fascinating and unique periods in the history of life on Earth and is of great importance to understanding of how and why the earliest animals evolved and diversified. The base of the Ediacaran period documents the end of a dramatic event in Earth's climatic history. The planet had suffered two major glacial events in the interval immediately before the Ediacaran, named the Sturtian and the Marinoan glacials. Each of these is thought to have lasted for several million years and may have been global in their extent. Such severe glacial conditions would have cooled the planet significantly and covered vast swaths of the oceans in ice. The severity of the events is a matter of substantial scientific debate, but they are often referred to as noble Earth events. The planet was also undergoing a major rifting event with the continental tectonic plates, which had formed a supercontinent called Rodinia around 700 billion years ago, fragmenting and drifting apart. The breakup of Rodinia led to significant volcanic activity and the creation of large areas of shallow seas that may have provided ideal conditions in which life could thrive and diversify. Towards the end of the Ediacaran period, another large landmass, Gondwana, began to form. These tectonic upheavals may have introduced large quantities of nutrients to the oceans, encouraging blooms amongst populations of planktonic organisms within the oceans. Perhaps most importantly for the development of the animal-dominated ecosystems that followed, during the Ediacaran period, the Earth's oceans became fully oxygenated. Prior to this, although the shallowest waters may have contained some oxygen, much of the deep ocean is thought to have been anoxic and rich in sulfur and iron. Such conditions would have been toxic to most higher life forms. However, during the Ediacaran period, oxygen began to penetrate into the deeper oceans and build up in both the water column and the atmosphere, so that by the Cambrian period, oxygen levels were not only roughly similar to those today, but were also consistently stable. Against this backdrop of climatic, tectonic, and geochemical change, the first communities of diverse, large, and complex organisms evolved and radiated around the globe. These organisms appear in the fossil record around 580 million years ago and thrived in many environments right up until the basal Cambrian boundary at around 541 million years, although they almost certainly included algae, protists, and some of the earliest recognizable animals. Many Ediacaran fossils are unlike any known organism, living or dead. The Ediacaran microbiota therefore continue to represent some of the most intriguing fossils in the entire geological record.
Okay, thank you for that. So, next is number two. Number two is Cryogenian period, 700 to 635,000 million years ago, an age of planet-wide glaciation. So, glaciation means it is a formation or movement and recession of glaciers. Snowball Earth hypothesis. Glaciation extended to about 30 degrees north and south latitudes. Snow and ice reflect most incoming sunlight back into space. This means that Earth's oceans and land surfaces were covered by ice from the poles to the equator during at least two extreme cooling events between 2.4 billion and 500 million years ago. Supercontinent Rodinia breaks up. Rodinia, from the Russian Rodina, meaning motherland birthplace, was a Neoproterozoic supercontinent that assembled 1.1 to 0.9 billion years ago and broke up 750 to 633 million years ago. Rodinia broke up in the Neoproterozoic, with its continental fragments reassembled to form Pannotia 633 to 573 million years ago. Tonian period. So next is Tonian period, 1000 to 720 million years ago. Diversification of Acritarchs. The Tonian era is the earliest geologic phase of the Neoproterozoic era, from ancient Greek Romanized, meaning stretch. It lasted from 1000 to 720 million years ago. These dates are determined by the ICS using radiometric chronometry rather than stratigraphy. The Tonian period was the planet's last period of relative inactivity, both in terms of its atmosphere and geology. At the start of the Tonian period, Earth's land masses were consolidated into a single supercontinent known as Rodinia. The supercontinent, however, began to fracture and break apart near the end of the Tonian period.
Thank you for that. So next is we will tackle about Mesoproterozoic. It occurred between 1,600 to 1,000 million years ago. The Mesoproterozoic is the first period of Earth history with a respectable geological record. The continental masses of the Mesoproterozoic are more or less the same ones that are with us today. This is also the period when the formation of the Rodinia supercontinent occurred, as well as the breakup of the Nuna supercontinent. So the period is marked by further development of continental plates and plate tectonics. At the end of this era, the continental plates that had developed were more or less the same as what we have today. So this period is also known for the first evidence of large-scale mountain building, namely with the Greenville orogeny, for which extensive evidence still survives in the geologic record. So the Mesoproterozoic is also the most prolific time for the stromatolites, as they began to decline during the Neoproterozoic. Perhaps the greatest evidence recorded from the Mesoproterozoic period is the first known presence of sexual reproduction, which greatly increased the complexity of life to come. So it was also the start of development of the communal living among organisms. So the multicellular organisms. So next is we will tackle about the subdivisions of Mesoproterozoic. So first is Tenian period, 1,200 to 1,000 million years ago. So Tenian is a Greek very narrow, referring to the narrow belts that formed during this period. So what happened during this periods are no clear evidence of life colonizing land, possible prokaryotic organisms on land, microbes may have present on land. Next are the maximum diversity of stromatolites, profuse growths of stromatolites along the coastlines, the atmosphere, which had contained about 1% of oxygen at the start of the Mesoproterozoic, had increased the oxygen content to no more than 2 to 4% at the time of the formation of Rodinia. So there was no ozone layer, and the formation of the supercontinent Rodinia during the Greenville orogeny. So during this period, it is lasted from 1,200 to 1,000 million years ago. It was the final geologic period of the Mesoproterozoic era. So these dates are chronometrically defined rather than geologically defined. So the name comes from the narrow polymetamorphic belts that involve at this time. So the Ictasian era preceded and was completed by the Neoproterozoic era.
Now let's proceed with the second subdivision of Mesoproterozoic era, which is Ictasian period. It happened around 1,400 to 1,200 million years ago. Ictasian is Greek for extension, signifying the extension of the continental land masses. So what happened during Ictasian period? Geologically speaking, the continent continued to grow in size, continue to drift apart as they grow, and expansion and drifting apart continued through the middle of the Ictasian period. Another thing is that the origin of eukaryotes happened during Ictasian. Well, we don't know when the first eukaryote evolved, right? But we can be generally sure that it happened by the end of the Ictasian. In fact, we cannot only be sure that eukaryotes were present, but the eukaryotes of 1,200 million years ago included both green chlorophyta and the red rhodophyta algae. Similarly, we do not know exactly what Craton made up, the supercontinent of Rodinia, but we know that it began to assemble by the end of Ictasian. The origin of sexual reproduction was recorded, finding evidence of sexual reproduction in the fossil record, and prokaryotes do not perform sex that was being recorded, and reproduction, this is strictly eukaryotic function. Do you know about the first sexual reproduction and when it took place? So, it is in the period when the first sexual reproduction had taken place. Of course, according to evidences, the microfossils of Biomorpha phaeobescens had proved that fact. Even the Hunting Formation, which is 1.2 billion years old, dated back to this period and contained these microfossils which support the fact of the first sexual reproduction. Note that the Baugamorpha pubescens, these are type of red algae unknown to the first organism exhibition sexual reproduction. These organisms are also among the complex multicellularity, and sexual reproduction is an essential feature of this organism. Another interesting fact about this multicellular organism is that this organism cannot exist in reproduction, means copying of one cell to itself. The next subdivision that we are going to tackle is all about the Calimian. Calimian period happened around 1,600 to 1,400 million years ago. It is also a Greek word which means cover, indicating the expansion of platform covers, which are layers of igneous or sedimentary rock that accumulate over cratons. One highlight is the breaking up of supercontinent Columbia. It is also a time of continent building where the earth crust thickened due to the deposition of the rock on top of the olden rock. It is also due to the repeated subduction, transformation, shearing, and other tectonic activities. Around 1,500 million years ago, fossils appear of possible eukaryotes. Tapania plana is the first recorded one. Eukaryotic supergroup probably already diverged by early Mesoproterozoic time. To sum it up, what happened during Mesoproterozoic era? So, the geophysical, the breakup of the supercontinent Columbia, as I've mentioned earlier. The second one is the formation of the supercontinent Rodinia. And the third is the origin levels of 1 point, oxygen level of 0.1% of current levels. And about the biological, the maximum diversity of stromatolites, the origin of sexual reproduction in organism, and probable appearance of multicellular organism, such as the origin of the green plant lineage.